So a signal is given here, that is our y of t is given here. We have to find out the Fourier transform of y of t, right? That is y of omega. I'm just going to draw our y of t. This is our rectangular function shifted, right? So I can write y of t as rectangle that is shifted from, actually rectangle has a form like this, right? 0 and it is now at 3/2. So I am going to write it as rectangle t minus 3/2 divided by tau. Tau, that is the time period of a rectangle, that is 1 to 2, it is 1 only. Okay, this is this signal, and the next one, this one is shifted to the left side, that is t plus 3/2 divided by 1. So y of t, I can write it as rectangle t minus 3/2 plus rectangle t plus 3/2. A is 1 here, so I am not going to write it for now. And we have to find out omega, y of omega, right? So what is A into rectangle of t divided by t? T divided by tau, let's say tau, that is AT sinc ft. Okay, please remember this formula. The derivation of this formula is given in my study notes that is posted in my Facebook page and also in my Instagram account, the link to which I am giving in the description box. Please have a look at there. I most of the time I upload these study notes that are required to solve the problems. So please have a look at that account. So y of omega, I can write rectangle t minus 3/2. What happens when it is time shifted? X of t having x of omega and x of t minus tau, let it be tau. Okay, tau will have Fourier transform equal to e raised to j omega tau into x of omega, right? So rectangle of a t minus 3/2, first of all I will find out the Fourier transform of a rectangle and then I will multiply it with e raised to j omega 3/2. Okay, so AT sinc ft, right? A is 1 here, t is 1 here, so the rest of it is sinc f. AT sinc f into e raised to minus j omega 3/2. Sorry, minus, not minus, it is plus. If minus is coming here, plus will be coming here. Okay, plus here also it will be sinc f into e raised to minus 3/2 j omega. Okay, and now we'll simplify it. Sinc I am taking outside because it is common. The rest of it there is e raised to 3/2 j omega plus e raised to minus 3/2 j omega. We know that cos theta equal to e raised to j theta plus e raised to minus j theta divided by 2. So I can replace it with 2 sinc f into 2 e raised to 2 cos 3/2 omega, right? So it is sinc f into 2 cos, instead of omega I am going to write 2 pi f. Okay, so the final answer is 2 into sinc f cos 3 pi f. Okay, you sinc f cos 3 pi f. Okay, now let's move on to the next question. In this question it is given that x of t is equal to 2 into e raised to minus pi t square is convolved with h of t equal to e raised to minus pi t square divided by 4. If the resultant signal is y of t, that is x of t convolution h of t, we have to find out the energy of the signal x of t. Actually, the energy of the signal x of t is asked here, which is equal to minus infinity to infinity x of t whole square into dt, right? So it will be minus infinity to infinity e raised to, sorry, that is 4 into e raised to minus 2 pi t square into dt. It will be equal to 4 into minus infinity to infinity e raised to minus 2 pi t square into dt. And we know, please study this property, e raised to minus infinity to infinity pi x square equal to 1. Okay, so we can make this into that. Okay, that is our A. So 4 into e raised to minus infinity to infinity instead of pi into 2 square. Okay, rearrange it and write it like that, and I'll get, okay, minus infinity to infinity, let 2t square equal to x square. So it will be 2 into 2 dt equal to 2x into dx, and dt can be replaced by x divided by 1 by 2 into x by t into dx. From here I will get a root 2t is equal to x, that is x by t equal to root 2. So instead of e raised to minus pi x square, so instead of 2t square I am going to write x square into dt. Instead of dt I am going to write 1 by 2 into root 2 dx. Okay, so it will be divided by root 2 into integral minus infinity to infinity e raised to minus 5, and this will be equal to 1. So the answer will be 4 divided by root 2. If we simplify, it will be 4 root 2 divided by 2 or 2 root 2. Okay, simply 2 root 2. So the answer is 2 root 2. Now let's move on to the next question. A signal x of t equal to, again x of t equal to the same question it is asked here, is convolved with h of t. If the resultant is y of t, the value for y of t at t is equal to 0 is. So e raised to minus pi t square is e raised to minus pi f square, whose Fourier transform is e raised to minus pi f square, and e raised to minus pi t square divided by 4 is, we know that x of t having Fourier transform x of omega, when it is x of 2t we get 1 by 2 x of omega by 2, right? So here there is a time scaling, that is e raised to minus pi into t divided by 2 the whole square, right? That is happening here. That is our a here is 1 by 2. So instead of 1 by a, I will write 1 by 2 into e raised to minus pi into f divided by 1 by 2 the whole square. Okay, so what we will get, 2 into e raised to minus pi 4 f square. Okay, so that is it. Our x of f equal to e raised to minus pi f square and h of f equal to 2 into e raised to minus pi into 4 f square. Okay, and now we can go to y of f. Y of f is equal to, actually y of t equal to what, x of t convolution h of t. In the frequency domain, it will be y of f is equal to x of f into h of f, right? Convolution in time domain is multiplication in frequency domain. So it will be pi f square into 2 into e raised to minus pi into 4 f square, which is equal to 2 into e raised to minus 5 pi f square. And we can find out the question it is asked y of t at t is equal to 0. So we can find out the inverse Fourier transform, that is minus infinity to infinity y of f into e raised to j into 2 pi f t dt, right? So it will be, excuse me, okay, so y of t equal to, and also at t is equal to 0. So when t is equal to 0, what happens? Y of 0 equal to integral minus infinity to infinity y of f only. This term will be equal to 1, so we don't have to take it. So instead of y of f, we are going to write 2 into e raised to minus 5 pi f square, right? So pi f square, and we'll substitute like we did in the previous question. Minus pi into 5 f square into df. Instead of 5 f square, we are going to write x square, and substituting that here, we'll get 2 into integral minus infinity to infinity e raised to minus pi s square into dx divided by root 5. Is there a 2 here? Did I miss something? Okay, there is a 2 also here, right? So, okay, I'm sorry. Okay, this is 4. Okay. This is 4, okay. There's no other changes. This is 4. So, it is 4 by root 5 minus infinity to infinity e raised to minus 5 square t square, which will be equal to 1. So the answer is 4 by root 5. Okay, now let's do the last question for this video. It is x of t is equal to 2 into e raised to, the same question is asked, the resultant y of t, the energy of the signal y of t. So y of f, we know that it is 4 into e raised to minus 5 pi f square into 5 pi s square, okay. And the energy of y of t is similar to integral minus infinity to infinity y of f a whole square into df full. So we are going to take the modulus and square it. That is 16 into e raised to minus 10 pi f square into df. It will be minus infinity to infinity by doing the substitution method that we did in the previous questions. We will get 16 divided by root 10. Okay.